going to take a look at 6.5, which is all about graphing the kind of functions that we've talked about this quarter. And graphing's always been a part of every chapter that we've done this semester. So it's no surprise that we have to hit the graphing with the radical symbol now. So the first thing you see the vocabulary word radical function, which is what we've been dealing with the whole chapter. Well, remember, another word for radical is just root. So if we're talking about a radical function, we're just talking about a function that has a root in it. The simplest of those functions is y equals the square root of x, but we'd also be talking about y equals the cubic root of x, and y equals the fourth root of x, and y equals the fifth root of x, and so on. So what we're going to take a look at today is how do you graph those functions. And just like always in the past, we've had something that is called a parent function. And remember, parent function just means the most basic graph of that function form. So if we're going to try and graph the function y equals the square root of x, the parent function is always going to look the same. We're going to take a look at that in just a second on your calculators. But we've also been talking about domain and range this chapter. So they're going to remind you that the domain of a square root is always x is greater than or equal to 0. We saw a little bit of that back on Thursday when we were talking domain. We also know that the range is always y is greater than or equal to 0 when you're in the most basic parent function. That is the domain and range. Obviously, that's going to change if your function changes a little bit. Now, for the parent function of cubic root, then we have g of x is the cubic root of x. The domain and range are a lot simpler because, look, the domain and the range are all real numbers. All right, that was cubic root. So let's just suppose you were dealing with the fourth root. Which one do you think that would be most like? The square root parent function or the cubic root parent function? If we were dealing with the fourth root? Probably the square root. And what if we were dealing with the seventh root function? Which one is it most like, do you think? The cubic root, yeah. So basically, you can also take a look at these and think about them as the even roots and the odd roots, okay? So grab your calculator. We said we were going to take a look at them using a calculator. So grab yours. If you don't have one right now, just look on with somebody so I don't have to take a time out to get calculators out. Okay, here's what I want you to look at. In your first equation, y sub 1, put in the square root of x. Square root of x. I've got both mine in, so I'm ready to go, but you don't have to have both yours in right now. Square root of x. And let's look at the graph. Square root of x. So the parent function of the square root of x looks like that. Because remember, the square root of x should be the inverse of x squared, and x squared went like this, right? That was x squared. So it makes sense that the square root of x is going to curve around this axis. My question is, how come the bottom dotted line is missing if that's the inverse function? Well, what do you know about functions? What kind of test do they have to pass? Vertical line test. If we put this bottom half of this graph down here, would it pass the vertical line test? No. So remember, our calculators can only graph actual functions. So if we're going to truly talk function, that's why the square root function is only this top branch of that parabola. But that's what it always is. So that is why, what is the domain always going to be on the parent function? Where does it start? The domain? Greater than or equal to 0. Yeah. And the range is also greater than or equal to 0. Range just means where's the y. So that's why the domain and range is what it is. So this goes through 0, 0, 1, 1, 4, 2, 9, 3. If I went out to 16, how far up would I go? Because what's the square root of 16? 4. That's how I'm getting those numbers. Okay, let's take a look at the cubic root. You probably have an idea of what that's going to look like. Cubic root, I'm going to go turn off my squared one here. And if you haven't put in the cubic root, please put it in. You can get the cube under the math key, or you could put x to what power? X to the 1/3, correct. Either one is going to give you cubic root. So let's take a look at what it looks like. It looks like this. So again, it's an S-curve, but instead of the S-curve wrapping around, let me delete this for a second. Instead of the S-curve wrapping around the y-axis, we're going to get an S-curve wrapping around the x-axis because it's the inverse. So here is the inverse of what was x cubed when it wrapped around the y-axis. Remember that? So now we reflect it over and we get this. So what's the domain of the blue one? What x's values does it cover? All of them. Yeah, that's why it's all real numbers. And if we went out long enough, it would get high and low enough. That's why the range is all real numbers as well. So that is what we are looking at today, those graphs. That's the parent function, but that doesn't mean that's the way every single one of them is going to look, because just like in the past, once we have the parent function, then we have the a, the h, and the k to deal with, right? We're still going to have an a, an h, and a k to deal with in these root functions as well. All right, so let's start with example 1. It says we are supposed to graph, need a 6-5. We are supposed to graph y equals 2 times the cubic root of x. Well, if you just type it in your calculator, go ahead, type it in, because I want you to see what it looks like. And then we'll go through all the work of graphing it. Y equals 2 times the square root of x. Is it an S-curve or is it a single branch? Yeah, it's a single branch. All right. Is it just like the parent function? No, what changes about it? Yeah, it's a vertical stretch. It goes up just a little bit high. It's a little bit more of an arc to it. Okay, well, let's figure out one of the ways we could figure out what that graph would be if we did it by hand. And that's what your note guide has you do in example 1. It says, all right, so we got this graph y equals 2 times the square root of x. It says to make a table of values. Remember, if all else fails, make a table of values. That will work on every single graph. So if you really don't know how to graph something, just make a table of values. So let's do that. Let's put a 0 in for x. What do we get for y? 0. Put a 1 in for x. What do we get for y? If I put a 1 in for x, what do I get for y? 2. If I put a 2 in for x, what do I get for y? Yeah, ugliness. So I'm going to skip that one for right now. What if I put in 3? More ugliness. I'm going to skip that one, and I'm just going to go to 4. If I put a 4 in for y, what do I get? 4. So you know when you're doing square roots, don't do a table of 0, 1, 2, 3, 4, because that's ugly. Choose good numbers, like perfect squares would make nice, cool numbers. Now we can graph this thing. It starts at 0, 0. It goes over 1, up 2, and over 4, 1, 2, 3, 4, up 1, 2, 3, 4. You know in general what that thing's going to look like, so put your little curve in it. And there's the graph of 2 square roots of x. Now, the parent function, well, that went through 0, 0, 1, 1, 4, 2, right here. So if we were comparing this, I think you said it earlier, Zach, if we were comparing this, what is this one compared to the parent? You said it earlier. You compare this to, yeah, it's a vertical stretch of how much? Everybody? 2, all right? So when it says to compare it down below, you want to talk about the domain and the range and then the shape. So first of all, the radical of the square root is always non-negative, so domain is still x is greater than or equal to 0. The range is still x is greater than or equal to 0, or y is greater than or equal to 0, because it didn't move anywhere. All it did is have a vertical stretch of 2 because it had an a of 2. So nothing new there. All the a's and the h's and the k's still do the same thing. Okay, so let's take a look at a cubic root. We know the general shape of it's going to be what? Cubic root. What's the general shape, Brian? Basically an S-curve. And he said how it's around the x-axis. So let's take a look at what we got. Again, it says let's just make a table of values. So we want the cubic root. Well, I'm looking at these numbers and I'm thinking, really? We want to make a table of values with these numbers? Isn't that going to be kind of hard? If you put in a -2, first of all, can you get a value if you put in the cubic root of -2? You actually can because it's cubic. So you can, but it's going to be ugly, isn't it? It's going to be ugly. Okay, just give me a value just for fun so we can fill this in. Somebody give me something. What do we get? No, I mean, give me the actual value, even though it's a decimal and ugly. Anybody got it? -0.63? -0.63. I'm going with it because I'm not hearing anybody tell me that's wrong. Yeah, that's what I got. You couldn't see my big old dot there? I think you're right. It's positive. Is it still 0.63 though? Okay, thank you. Okay, now if we put in -1, I know we're going to get -1/2 because I know the cubic root of -1 is -1. If we put in 0, I know we're going to get 0. If we put in +1, I know we're going to get -1/2. Oops, did I do this one wrong? This is +1/2, isn't it? Yep, thank you. And if I put in 2, I'm going to get another ugliness, but I know it's -0.63, right? Okay, so here's the deal. When I go to graph this and I go 0, 0, okay, that's fine. -1, +1/2, well, that's going to be really close right there. And -2, +6/3, that's a little bit higher, or 63. Now I go the other way, +1, -1/2, +2, -6/3. So I guess it gets the job done. You're just going to have a calculator to get those ugly numbers. All right, so here's the graph right there. It's an S-curve. Now we're supposed to compare that to the parent function. This is the parent function, 1, 1, 8, 2, which is way out here someplace. Okay, there's the parent. So let's talk about it down here. What does it say? Domain and range. Well, we have the cubic root. What are the domain and range of the cubic root? Every single time. Every time. All real numbers. You don't even have to think. All you have to think is like, oh, it's an odd root. I know the domain and range is all real numbers. Every single time. There's very few things in math I can tell you happen every single time, but that's one. Okay, so now let's talk about this vertical thing. Stretching, shrinking, what is that A making that graph do? It is shrinking, yep. It's a vertical shrink by a factor of what? What was my A? -1/2. So that means what else did it do? It reflected, and that's why they listed that right here in your notes, because it was a -A. So see, it's all tying together. It's the same thing we did before with the A stuff. A little harder to graph because you have to deal with roots, but otherwise same thing. Okay, so you have 2 functions to graph right now in the checkpoint. Please do those right now. So in the first one, what's it going to end up looking like? A branch or an S-curve? It's an S-curve. All right, so let's take a look at this thing. If we make a chart, I know 0 is going to go with 0. Ooh, my board's up. 1 is going to go with what? 1 goes to, you put a 1 in, 2. So 1 goes to 2, And then the next thing I would choose is a cubic root. Well, I'd like to choose an 8. That's way off the graph, right? But if I did choose an 8, 1, 2, 3, 4, 5, 6, 7, 8, what does it go to? Do you see why I chose an 8? Because it has a nice little cubic root to it. So I know it would go to 4, which is way off the graph, and I know that's not real practical. So if you found some numbers like 2 or 3, you're going to get the same curve to it, something like that. Okay? Oh, I didn't do the bottom half. So the bottom half is always going to be the same shape. So I know if I went over 1 this way and up 2, I'm going to go over 1 and down 2 this way, because it's always going to be symmetrical. So that's one nice thing about making your chart, too. If you got the left half done, you got the right half done, and vice versa. Okay, number 2, what shape is that thing going to be? S-curve or half a parabola? Half of a parabola or half of an S-curve, yeah. And it's going to be upside down because it's a -2. So I know it's going down here someplace. So 0, 0, what did 1 go to? -2. What did 4 go to? -4? If I put a 4 in there, I get the square root of 4 is 2. 2 times -2 is -4. So this is where this one's going. So it's a reflection and a vertical stretch of how much? 2. Yep. Okay. So if you just have an A value on here, if you just have an A, it's probably easiest to just plug some numbers in and get some values and plot the graph. No problem. Now, if you also have H and K, now what am I talking about H and K? Well, remember way back in quadratic equations, we had this whole complete thing when we were trying to graph. And we said that the A is what determined if it was a right side up or an upside down parabola, and if it opens really wide or if it opens really narrow. And what did we say about the H and K? It's the new vertex. Yeah, it's how the X and the Y move. But remembering it's the new vertex is probably the best thing to do. Well, now we're going to have the same thing in radical functions. We just don't have vertices. We don't have a vertex of a S-curve. We don't have a vertex, we don't have a vertex of a half parabola, but it's going to have the same importance. It's that beginning point or the middle point in the case of an X-curve. So look at what we have. We still have an A. We already covered those. We're still going to have an H, but look where that H is. It's still with the X, which ends up being under a roof. We aren't going to see parentheses anymore. But we've got a roof that groups it, so we can still tell what the H is, and then the K is the number outside the roof, not within the parentheses. And you know what else is the same? We still have a minus in front of that H, just like we always have. So when you look at the H, you got to take the opposite. Nothing has changed. H and K still move the same directions. So let's try and tackle that with a radical function. Here's what you need to fill in. In your 2 steps, number 1, they suggest to sketch the parent function first. And then once you have that sketched, you can translate the graph H units or K units accordingly. All right? So we're not going to make a table. But if all else fails and you don't know what you're doing, what should you do? Make a table. But we're going to try and do it without a table, see if we can get it to shorten up a little bit. Okay, here's our problem. Graph y equals 3 times the cubic root of x minus 1 plus 2. And then we're going to look at the domain and range. Well, if we're going to start this thing, let's start by just graphing y equals 3 square roots of x. Is it going to be a half parabola or an S-curve? Half a parabola. So this first little one, this parent, so to speak, I know it's going to go through 0, 0. I know it's going to go through 1 what? You can do it in your head. 1 what? 3. 1, 1, 2, 3. Okay, then the next one I'd pick, since it's square root, the next number I'd pick is a 4, because I don't want to have to use the calculator thing or the decimal. So the square root of 4 is 2. 2 times 3 is 6. So I go over 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Now, that is just the problem with just the A in it. But that thing is translated how? Where is my new so-called vertex, even though that's really not the word they call that? Where is it going to move to? Okay, I heard it. 1, 2. Because right here, H is 1, K is 2. So shift the graph 1 unit which way? Left or right? 1 unit to the right. And how many units up or down? 2 up. You're right. Up 2. Okay? So take each of those points we have and move them accordingly. Go ahead. Where did I write? No, that's the point it goes through. The parent function goes through 1. Actually, it's 3. Thank you. Well, it's 3, but not 2. Yeah. Because if I go put a 1 in here, I get 3. So I'm just substituting to get that first one. Okay, so now what we have our new graph that we're supposed to shift 1 unit to the right and 2 units up. So let's do that. Here's a point at 0, 0. Go 1 to the right and 1, 2 up. And there you are. There's your new starting point. Here's our point at 1, 3. Go 1 to the right and 1, 2 units up. And there's my new second point. And then here I have this point at 4 something. I go 1 to the right and I go 1, 2 units up, and I happen to run off the graph. That's life. I start here and I go that direction. Don't go beyond this point, because parent or graphs of square roots do not go all over. They have a direct starting point and go in one direction. An S-curve goes forever, but not these. Okay, so let's talk about the domain and range. Well, if the graph shifted, shouldn't the domain and range shift as well? And shouldn't it shift in the same direction? So instead of x being greater than or equal to 0, which is what it is on a parent function, what is this one going to be? X is greater than or equal to what? 1, because we went 1 to the right. So x is greater than or equal to 1. And what do you think is going to happen to the range? Yeah, probably move the same way as the graph, so that's why the range moved to y is greater than or equal to 2. All right? Not so bad. Yeah. So now we get to do a cubic one. Same process. The only difference is we're going to have an S-curve instead of a half a parabola. So S-curve, S-curve, let's see. Well, let's start with this. Let's start graphing just the parent function with the a, which looks like that. So I know it's going to go through 0, 0. So I put in a 0, I get 0. If I put in a 1, what am I going to get? If I put in a 1, what am I going to get? Put a 1 right here. Negative 2, yep. Oh, and they go by 2s. I hate that. So they go over 1, go down 2. The graph is going by 2s. That's why I went right there. Okay, put in an 8. What do I get? Put in an 8. What's the cubic root of 8? 2. What's 2 times negative 2? Negative 4. So 2, 4, 6, 8 goes down to 2, 4, negative 4. Now, I know the other side's going to be the same thing. Symmetrical. So if I go over negative 1, I go up. I know. Did I do that right? 2, 4, 6, 8. Negative 4. What's that? Well, yeah, if I put an 8 in there, that's my x. Clayton. Okay, 2, 4, 6, 8, 1, 2. Okay, there's my graph so far. But definitely I'm not done. Because how does that graph translate? By the way, if you want to fill in numbers here, negative 1, 2, and 1, negative 2 would be 2 possibilities. Alrighty, let's see. McKaylee, how's this graph going to move? Or if you'd rather say what's h and k, I'll take that too. You are so close. It is negative 2. What's -3. Thank you. So how does that move the graph, Jordan McKnight? If h is -3, how does the graph move? Not for the h, that's horizontal. H is horizontal. Left or right? Left or right? Left, how many? Yep. And this is up or down for the k. So up or down? How many? Up 2 when it's a -2? Down 2? Better choice. Down 2. All right? So take each of those points and move accordingly. We are going to the left 3 and down 2. So here's my 0, 0. To the left 3, 1, 2, 3, and down 2. There is my new central point, if you want to call it that. Then I'm going to take this other point I knew, which was 1, -2, and what am I moving? I'm moving to the left 3, 1, 2, 3, and down 2, 1, 2. It's a little harder thinking when you get counting by 2s. I don't like it. So then this point right here is going to move to the left 1, 2, 3, and down 1, 2. And this point out here is going to move to the left 3, 1, 2, 3, and down 1, 2. So here's where it's going. And I missed every one of my marks because my border's off. Thank you. So if you want to list points, -4, 0, it should be going through. -3, -2, -2, -4. If I did it accurately, that's the points it should be going through. And what about that domain and range? What is it going to be? All real numbers, because as soon as you see cubic, we know it's all real numbers, no matter what. All real numbers. Okay, you have a checkpoint. No, you have 2 checkpoints to do. Draw your graph, and please remember to list your domain and range. Go.